Hi friends, good morning. Please look at the next problem. See, this is problem number 20 friends. Problem number 20 of exercise 15.1 of probability chapter. Okay friends, problem is given in the description box too. Friends, suppose you drop a die at random on the rectangular region as shown in the figure. What is the probability that it will land inside the circle with diameter 1 meter? Friends, this is the rectangular region. This is the rectangular region with length 3 meters and breadth 2 meters. So, a die is thrown at random on this rectangular region. A die is thrown on this rectangular region. Now we want the probability that the die will land on the circle. Will land on the circle of diameter 1 meter. Of diameter 1 meter. Friends, here we have to consider the area of the rectangle. That is, this is the total region. Total region, that is total area of the rectangle as n of s. So, n of s, that is the total outcomes. Just like our total outcomes, we have to consider the area of the rectangle, that is the total region, as ns. So, area of the rectangle 3 into 2, that is 6 meters square. 6 meters square. This is n of s. Then let us, what is our favorable outcome? What is our favorable outcome? That is the thrown die. The thrown die will land inside the circle. Inside the circle. So n of e, let e be the event that the die will land in the circle. E, then n of e is area of the circle. So area of the rectangle is n of s. Area of the circle is n of e. So n of e is equal to area of the circle pi r square. Friends, diameter is 1 meter. Radius is 1 by 2. Pi into 1 by 2 into 1 by 2. That is equal to pi by 4 meter square. Pi by 4 meter square. Now we want the probability that the die will land inside the circle. So n of e by n of s. Required probability. What is that required probability? That the die will land inside the circle. That is our favorable outcome. That is the area of circle. Area of circle n of e by n of s, that is equal to pi by 4 by 6, that is equal to pi by 4 into 6, that is equal to pi by 24 is the required probability, friends. Okay friends, thank you. Have a nice day. Hi friends, good morning. Please look at the next problem. See friends, this is problem number 21 of exercise 15.1 of probability chapter. Friends, a lot consists of 144 ball pens, of which 20 are defective and the others are good. Nuri will buy a pen if it is good, but will not buy if it is defective. The shopkeeper draws one pen at random and gives it to her. What is the probability that she will buy it, or, and second question, she will not buy it? Friends, total number of pens. Total number of pens in the lot is equal to 144. Out of which defective pens is equal to 20. Then non-defective pens, that is good pens is equal to 144 minus 20. 124 pens are good pens. Here Nuri will buy the pen if the pen is good, that is if the pen is non-defective. If the pen is non-defective, so the probability that Nuri will buy the pen, the probability that Nuri will buy the pen, say the probability that Nuri will buy the pen, Nuri will buy, probability that Nuri will buy is favorable outcomes. So Nuri will buy the pen if the pen is good. So how 124, how many outcomes are favorable? 124 outcomes are favorable. Of course, total number of outcomes 144. So for 31s, for 36s, 31 by 36 is the probability that Nuri will buy the pen. So second question, the probability that Nuri will not buy, the probability Nuri will not buy the pen. So when Nuri will not buy the pen, if the pen is defective, so how many defective pens are there? 20 defective pens are there. So this 20 is our favorable outcome. So the probability that Nuri will not buy is equal to favorable cases 20. Defective pens is our favorable cases, favorable outcomes, and total number of outcomes 144. 20 by 144, for 5s 20, for 36s. So required probability is 5 by 36. So probability that Nuri will buy the pen is 31 by 36, and probability Nuri will not buy is 5 by 36. Okay friends, thank you. Have a nice day.